We have next two presentations coming up on the theme CT and Science Education. So I request Shivjit Singh, Gajendra Singh, and Upendra Pal. They are from Rajakiya Ashram Paddhati Inter College, Hardoli. Please. Next presenters. That's what I said. You have, right? Yeah.
So, very good evening to everyone. I know many of you are expecting a tea break, and I was too. But let's go with the presentation, right? Ma'am, one thing I just want to. I was sitting at the last, and one thing I was facing a difficulty is that the picture is not that contrast. So I think the characters are not legible. If I am correct with the last people, if they compare with me, characters are not legible. So if you can increase the contrast, so can they can see the words, because my presentation is not too much attractive, I know, but the content there is a bit of fabulous. So I want to share with the audience. So yeah, light closing will also work, I think. Yes, definitely. So my name is Shivjit Singh. Along with my co-authors, Gajen Singh is there and Upendra Pal. We are from Rajki Ashrampati College, Banda, Uttar Pradesh. So first of all, before starting with my presentation, I would like to extend my heartiest thank to CTIS community, TCS, CSpathshala, ISER, and all those people who are behind the curtains who put up this platform for educator like us, for all the peoples from the different disciplines, professionals, researchers to come and collaborate over here and discuss their viewpoint and how they are contributing to the city in their education part, in their schooling education. So, without wasting much of time, I would begin with my presentation. So, title of my presentation is it basically belongs to the chemistry title. So, it is unlocking chemistry with the. Is it not working? I think. Yeah. So my title of my presentation is Unlocking Chemical Mind, Computational Thinking as a Catalyst for Understanding. So, so can, yeah. So computational thinking as a catalyst for understanding. Yeah, you can go on with the next. So here I have just I will be discussing few of the activities that I have done in the schooling part, and children had get a lot of it. And I was also the part of the CTIS event last year also. And I see when the terms computational thinking comes, no, most of the activities or unplugged activities comes from the part of mathematics or from the physics. But I am from a different view that I have created something, some point with the chemistry also. So my first activity is deconstructing the invisible. Now, as the name suggests, deconstructing. Here will be here the child will be decomposing the unknown sample given to him, and the activity goes like that. This is, suppose it is a class, and the child, one of the child who will be contesting, will come up over here, and he will be given an unknown sample. I will give him an unknown sample, and he has to face that sample upfront in front of the spectator childrens. Now, the thing is that the child that will be holding the sample, he doesn't know what chemical compound does it have. So he has to ask some questions to the audience. Now the rule is you cannot go with the random questions like what compound I am getting. No, the rule is that the question you can ask is based on the uses and properties of that compound, right? And now how city is involved, that one more rule is there, that the answers would be coming in the yes or no format, like our computer does. Computer takes the form of the binary language 0 or 1. Here 0 is yes, 1 is no. So suppose how this activity works, I am going to tell you that suppose I am holding a very common compound. Most of you know it, like NaCl, so sodium chloride. Suppose I am holding it, right? And I don't know I am holding a sodium chloride. So I will say, I will ask you a question that which color does it compound have? So the people, no, I will say that, is it a white colored compound? The answer I will get in a yes or no format. If it yes, I will deconstruct that. Yeah, white color compounds. What I have heard, what I have learned, white color compounds. It might be a bleaching powder. It might be a sodium chloride. I will guess it. I will deconstruct my answer. The second question I will go on with that is it a commonly used salt? We know that sodium chloride is at our tablespoon salt we use commonly in our day to day. So I will deconstruct it. Yeah, the second point I deconstruct that. Yeah, it is a commonly used salt. In the third, is it prepared by some method like desalination of water or by osmosis process? If it works, if the student says, if the spectator, you audience says yes, it is, then I am ready with my answer that I have deconstruct what unknown salt I have containing. It is sodium chloride. So I've just taken a simple example, but think of how interesting it becomes when it is integrated with their curriculum part, students part, and I have given them the compound of the class 11th or 12th what they study in a syllabus. Now they have to deconstruct them. So it becomes difficult also. They have to encroach all the debugging part, the troubleshooting, and have to critically analyze the data that yes, what yes or no format, and he will go on with the answer. Now, the student who will able to deconstruct the unknown compound with the least number of question is the winner in our activity. And we used to do this activity in our classroom, and we get a very great response because yeah, we had a contesting spirit in ourselves that we also like to win, right? So student also had a very good spirit over them, and they take a part in those activities very firmly. So there are just images of that how these activities was done in our classroom part. So can we move on to the next slide? Yeah. I think pen is not working. You can do it with the, yeah. Next. Yeah. Just, yeah, this is how, yeah, you can see the child holding the sample of the compound he has given to him, and he will be asking the question to the spectator and that in the yes or no format. Remember, the language is yes or no format. Okay, I'm also running with a short of time. My next activity is the gridlock puzzle. So move on to the next slide. The gridlock puzzle I have created it is very interesting things. Just if you have a very simple sound of language, sound knowledge of chemistry, then I could able to help you explain what my gridlock challenge work is. We all know functional group. Might be have heard in any of your previous knowledge of your schooling, you might have heard of alcohol, ketone, carboxylic acid. I think most of you have heard it, right? These are the functional groups, and we know that they are interconvertible, right? Okay, so they are interconvertible. So in the next slide. So there are the nine methods by which, 8 methods by which they can be interconverted. So these are the methods. I'm not going into detailing because I'm not teaching chemistry, but it is these are the pathways by which they can be these gridlocks can be interconverted. Now, can you show us the grid? Yeah, this is the grid. Now here also in the horizontal row we have an functional group. In the vertical column we also have a functional group, and few of the hints are filled. Now the rule is, among those 8 reaction pathways, that paths that we have chosen, you cannot use one pathway more than once in a single row. That rule is, you cannot use one pathway more than in a single row. So when you like here, if I have used this particular pathway once, then I cannot use it in the second method. Now, if I go on with the next, if the child has chosen that, yeah, we can convert alcohol to carboxylic acid by this method and by ketone with this method. So, how can we convert? This is the first pathway, and if I go and go on with, if this is legible enough, he can go on with this pathway. Now, here he have to go with 3 steps. Here, 1 step is involved. Now, the slide is empty. Yeah. And just I'm going on explaining. Now here he is going with the 1 step, and here is going with 3 step. But if he have interchanged it, if I have gone with alcohol to carboxylic acid with water and alcohol to ketone with $O, then this complexation has been reduced with the 2 steps pathway. So think, this is the interpretation, that this is the critical evolving, that the child has to think that which reaction pathway he which has to choose. And now coming on to the outcome of it, do you believe that if he has solved this 8 into 8 crossword puzzle, how many reaction he has to go through it? 8 into 8, 64 reaction with a single puzzle he will be able to evolve out and come out with it. So this is the beauty of this, my crossword puzzle is, I could solve out. So just a second, one more minute if I could borrow out. And the next of my activity is that molecular simulation, visual simulation that we have created, but due to some technicalities or glitches I could not able to show you out. But those molecular simulations, we all know, there I have created, we ourselves have created some games like seesaw games that we see in a schooling part, and their student used to solve them and able to crossword with the things, right? So just due to lack of time, this is all about my presentation. Now, any question if I'm open with? Any question, Ivan? All right, fine. Thank you.
That's interesting. I think you can interact with and show your games. Thank you so much. Next presentation is from School of Scholars Wardha, Sarita Satone and Vrushali Date.
Good evening, everyone. I'm Vrushali Date.
I'm Sarita Satode. We are science educators from School of Scholar Wardha.
Today, we are presenting our topic Exploring Motion Pattern through Computational Thinking. It is implemented for grade 6 and 9th.
At our school, students struggle with the concept types of motion. Despite of textbook definition, they found it difficult to visualize and relate the concept with the real life application. Around 65% of the students face difficulty. So we shifted our approach and we designed activity-based learning integrated with the city skills.
In our first task, we introduced pen box motion activity, which beautifully merged art with physics. In this activity, students has used a pen box suspended with the strings. As you can see in the image, students are pouring pen into the box and move the box, which results into the beautiful patterns on the floor. So while performing this activity, we are encouraging students to not enjoy the patterns, but concentrate to connect it with the real life motion. So they had connected it with the real life motion, like swinging a pen box with the pendulum or swing, and even the splattered pen with the random motion of the dust particles. So by creating the patterns, analyzing them, and finally connected it with the real life application, they had understand the concept step by step.
We also encourage students to break down the concept into simple parts. And also, we didn't just ask them to identify the types of motion, but we guided them to analyze it, what type of force acting on it, what is the direction of the motion, is the speed changing or remains constant. So this helps them to link force, speed, direction to explore the motion concept. And again, they also started thinking about what the pattern look like, which type of where they had seen before, and this helps them in learning experientially relatable and interactive. Again, we also form the groups of the student where students explore the motion in collaborative and creative tasks. They uses pen brushes, droppers, rotating device to create and recognize the motion trails.
After these activities, students compared their outcomes and classified the patterns with the different types of motion, like a car for the rectilinear motion or the ferry wheel for the circular motion. Even they had observed students playing hula loop on the playground and identified it as a circular motion, or the student playing on the ground as a random motion.
We also explore the we also explore the motion by using the laser pendulum activity, where the students suspended the pendulum, laser pointer, asked them, allowing them to swing and also observe the reflected paths in the mirror kept below. This activity visualized the linear, circular, oscillatory, and complex motions by how depending upon the how the laser pointer moves. And again, in the we also integrated the fate simulation online digital tool, wave on a string, where the student changes frequency and amplitude to explore the oscillatory motion. And again, by using this fate simulation digital online tool, they explore the simple harmonic motion.
Actually, we had added here one video which might be run, ma'am, if it is.
No. Start next.
Okay, fine. We are going to next slide. Peer discussion helps students to boost up their confidence and even improve their application skill. This discussion cemented the connection between theory and the real life world. So, which helps to deepen the conceptual understanding of the students.
But of course, we face some challenges also. Uneven flow of the paint due to the uneven surface issue. Then again, laser sensitivity problem also, and unstable setup of the paint box. But we resolve this issue by group monitoring, tool calibration, and encouraging the peer discussion and observation. But the best part, these challenges become learning opportunities, and student applied the logical thinking and teamwork to overcome them.
The impact was powerful. Actually, both the activities shifted students from passive learning to the active exploration. Concept clarity roses from 35% to 85%. Students, those are actually they are means memorizing the definitions of the motion or the concept related to the motion. Now they are starting to apply the computational thinking skill to understand it, so their confidence, engagement, and the application skill has improved significantly. Combining hands-on activity with the computational thinking makes science more engaging, visual, and memorable.
These activities help them to explore and see the motion, action in motion, to by the simple experiment and hands-on activity and real life activities also. And student actively develop the CT skills in them, that is abstraction, logical reasoning, and pattern recognition.
Predicting motion effects encourage algorithmic thinking in students. And now students have started to apply this computational thinking in other science topics also, which make their learning more interactive. Thank you.
Any question? Okay, can we use certificates? Yeah. Since from the morning we are talking about computational thinking and unplugged activities, and I think that's the approach taken up by maximum teachers in this process of teaching and learning computational thinking. When we have received so many abstracts and the review was done, there were a lot of activities, there were a lot of abstracts based on unplugged. And that's why there is a demo session on the second floor and poster and demonstration. And this covers lot of unplugged activities across various subjects. So we break here for tea, followed by a poster and demo presentation on the first floor in the same building. Thank you so much.
Or two states, which district is nearby to Nagpur, for example. Okay. Then in abstraction, they use one color. Then after they follow the pattern. Second color is used for the anticipation. Then the next first color. But the pattern is that means by this we can use the two colors. If we use only two colors or three colors, then maps are like this. Means some districts are of same color. Okay. That means finger mixed with district. Not sufficient for this color. And since we can do this activity, and this is based on sample.
Bandits. Okay, okay. Smileys. I saw. Okay, but we can leave it in the
Actually, it is related to yes, biology concept is here. I have a resonance with standard 8 students, in which I choose two topics: microorganism and reproduction.
Okay, only biology.
Yes, yes.
You have to do second page, right?
No, but we all three of us.
Only one we missed actually.
Yes, ma'am. You did very well. You played very well, but only the last
Last one.
and even you know the answer.
No, I thought we are going to take out one more.
No.
Yeah.
The last.
Second chance to ask.
Actually, what happened if you got the same again? It will be
No, there is another one, right?
yeah, there are five, but if you do the same thing, same again, then
We know the answer.
yeah.
I will give.
I can try. I haven't played.
Okay, fine.
Also, you can
So
help
you
because
can
I'm
join,
zero in biology. I'm mathematics student. I don't know.
Please, please.
So
Okay. You go.
Come from
okay,
this
yeah,
side. So from here it's starting. Yes.
Yeah, from
Yes, this is the first one.
The first one.
Ah, you last
This is first one, second, third.
last one.
If all five you solve, then you have your result.
Okay, I missed the first part.
Or you have
I'm
missed.
helping you, so you have to share.
Okay, what is it?
let's take the.
First
I am a group of tiny living beings, some good, some bad, with no nucleus, they say. I help make cheese and cause to decay. What am I? Cause to decay.
Sugar.
It's living, so definitely not virus.
It's a bacteria in the form of
Prokaryotes. Yeah, prokaryotes.
That you carry. Nucleus.
Yeah, you
Yeah.
is neutral.
You guys are only gonna win. I am just taking this out.
I think this one is done.
Let's get a video, everyone smile. Okay, I'll take
स्वतः
Yes, then after yes, we focus on Maharashtra, but if they want pure no, not that. That's not CSR.
These two have come in one line. These two have come in
Yeah, you can do it. Yeah, I can see this presentation.
Normally we say 45 but in different how you
Sir was there for this.
for example, the it will be getting easy for them to recognize the time. We are going to put the so they consider and these four cards they will just flip it. Here everything is same. They will just flip it and again they will say in different ways. It's like past to three. So the minute hand will come over here, past to three. So they will shade this portion. If half past, they will shade this portion like this. They will just actually they will recognize that this portion is for this one. There is eyes. There are sneaks here. Yeah. But we have done for means numbers also. This is for English, but in class we have done for the mathematical operations also. With the help of this, we get their A to F, L, R, just the symbols are different. This we have interlinked with the mathematics, English, because the shapes are triangle, rectangle, circle, sphere, and all flowers, cross. These are the
And
symbols.
here A to F is written means they have to identify which letter is here. For example, A is here, then where is C, where is N? So their critical thinking also develop. And they they enjoyed it.
And this
to
helped
identify
them
their
to
family members'
remember,
name.
yes.
Memory game.
Memory game, yes.
So once they open it, they have to again close it.
No, ma'am. They need not to open. They just need to identify what is the symbol for letter A.
And their partner.
Because we have identified from A to F. So these are the letters and these are the symbols. You need to identify what is the first letter of your parent's name or what is the first letter of your sister's name so that they can recall and they can write this symbol on their paper. And they will tell us.
Partner will
Another
encode
partner
the
will
symbol.
encode. What is the symbol for this one? Then they open it and say A.
And
So
your mother
likewise
name
they
is,
are
for
going to
example, Sarika. So your mother name is Sarika. Like that.
like that. With their studies, with their CS module, VCT scheme. So for that we have done such examples and game for them.
For example, traffic light, there without saying anything with the help of only symbol, we will wait. Red means wait, yellow means stop and green means go. And we interlink with nearby places also. For example, symbols is there, plus means hospital, that is hotel and school.
Okay, one here and this here and okay.
One more.
Okay, okay. Three we have to
But
no, four we have to make.
Here it is not
Okay,
a
okay.
square.
How it
Three
was?
squares only. Three
How it
squares
was
only.
originally like this and where
This
was this?
one.
Okay, okay, let us.
Three squares only. But no extra mastic will not be.
Okay, okay, okay. Squares, not rectangles. They are same.
Only one.
Why not try the double length one?
Four, only four. 1, 2, 3, 4. 7. हाँ. और एक अटेम्प्ट है, मैं सिर्फ 2 ही किया था. आपका भी और 2 है. हम चाहें तो ट्राई कर लो.
Sir, हें ऑलरेडी केला तुमी सर तेका आनी कितें करपाचें
ना ते एक्झाम्पल
तेका कटींग
जाय जाल्यार एड करीत राव
diagonally in this diagonally. I'm taking colors according to my choice. Yeah. No two edges have become same color. That's why I asked according to my choice. Yeah. Do according to your choice. But you follow the pattern here. Yeah. You try on the map also. Yes. It's shiny. Use two colors please. Condition is that no same color. No anticipatory color.
normally or?
Yeah. You use only two colors first.